Welcome back. In this video, we are going to look specifically at what it means to have a cofunction and complements as related specifically to trig functions. So as a reminder, a complement or complementary angles are those with a sum of 90 degrees. So when we're dealing with right triangles, we're talking about the two smaller angles. Those would have to be complement. Now the reason why they are complement is because a right triangle means one of your angles is 90 degrees. And the definition of triangle says that all three angles must add to 180. Now one of the things that we can do is with our trig functions is we can break them into what are called cofunction pairs, which means each trig function has a very special cofunction pair that has to do with complements. So we're looking at complements of other trig functions. For example, when we talk about sine, its complement cofunction is going to be the cosine, but it's of 90 minus whatever your angle was. So the sine of your angle has a cofunction that would be cosine of 90 minus that angle. Now your tangent has a cofunction of the cotangent, and again at 90 minus the angle. And last we have secant. So secant has a cofunction in cosecant, where again we are at 90 minus the angle. Okay. Now note down here the reversals are true. So keep in mind that your reversals, the cosine of the angle, would be the sine of 90 minus that angle. Okay, so they can go forwards or backwards. Now one of the things that we have to be able to do is we have to be able to find cofunction values based on information given. Okay. So as an example, you need to use the cofunction and reciprocal identities in order to complete this little table. So first of all, we have the sine of 64. Its cofunction is going to be the cosine. Now if we did 90 minus 64, we would get 26. So the sine of 64 is the same as the cosine of 26, which in turn is going to be the same as 1 over the cosecant of 64 degrees. So you kind of have to have an idea on how to go back and forth depending on what you've been given so that you can solve your problem. So let's use this idea to do a couple of examples. So here we go. First we want to express each of the following in terms of the appropriate cofunction. Now you can check using your calculator to verify, but you need to make sure that you know how to do it by hand as well. So we want the cotangent of 135. So one thing we have to remember is that its cofunction would be the tangent of 90 minus the angle. Now what makes it kind of interesting is the fact that this is 135. So some of these are going to end up being negative values. So in this case, we would do the tangent of 90 minus 135. So when you actually do that measure here, you're going to come out with tangent of negative 45 degrees. So now one of the things that we need to do is we need to know what the actual, say, value would be. So in this case, this is where you could just go ahead and use your calculator. So here you would just simply, in your calculator, you would do tangent negative 45 and hit enter. And notice it gives you a -1. Now if you think about its triangle, that should make a whole lot of sense. Okay? So here we would have that this is equal to -1 as a result. Now the next one is the secant of 216. So remember, when we're talking about the cofunction, we are talking about the cosecant of 90 minus the angle. So in this case, we would have the cosecant of 90 minus 216. So this is going to end up giving us the cosecant of -126 degrees. So we would use our calculator yet again in order to find that. Now remember, because it's a cosecant, we have to use its opposite. So we would have 1 divided by the sine of -126. And then we get -1.236 and then 1. So it's always a good idea, unless told otherwise, to go out maybe 4 decimal places. And so here we would have that this result is -1.2361. Last but not least, I have a radians here. And so in this case, we've got that the cofunction would be the secant of 90 minus the angle. But here we're in radians. So what you have to remember here is that we have to recall that 90 degrees is the same as pi over 2. So in this case, we would be dealing with the secant of pi over 2 minus my angle. So here we've got the secant of pi over 2 minus 8 pi over 3. Again, remember, you need to have a common denominator. In this case, between 2 and 3, your common denominator would be 6. So combining our terms ends up with the secant of -13 pi over 6. And then we would go ahead and use your calculator. Now since this is secant, the opposite would be the cosine. So in this case, again, what we would do is we would do the cosine, we would do 1 divided by the cosine, and this would be -13 pi, and we'll divide that by 6. And so here we get, we need to make sure that was the degree measure. We need to have the radian measure. So one of the things you'll notice, and I do it all the time, is you always need to double check your mode. I always tend to forget. So let's try this again. 1 divided by the cosine of -13 pi divided by 6. Close it, and that's a little bit better here. So we get 1.1547 as our result. So remember, if you're working with pi, those are your radians. So make sure your calculator's in radian mode. If you're working with degree, then make sure your calculator is in degree mode. So that is kind of everything you need to know to get started with the idea of cofunctions and how they relate to trigonometric ideas and identities. So if you feel like you need any more examples, please let me know. I'd be happy to work those out. Otherwise, I look forward to seeing you next time.